Good morning, viewers. This is Kasturi Day. So I'm back with the physics chapter, which I was discussing in my last few videos. That is measurement and experimentation chapter. Few numericals are left. So I'll discuss today that. And in my next video, I will start with the new biology chapter. Okay. So before I start, I will request you to please do subscribe so that you can get the notification of my next video. And if you are liking it, press the like button and share with your friends so that they can also be benefited from these videos. Okay. And last but not the least is that you should meditate before sittings to your daily routine, that is studies. Okay. The students and the elders who are assisting you, they should also meditate to lead their whole day in a very peaceful way, in a well-mannered way, you can say well-planned way. Okay. So let me start with the first question for today. Is the wavelength of light is 589 nanometers, and what is the wavelength in angstrom? Excuse me. So 1 nanometer, we know it's 10 angstrom. Therefore, 589 nanometer will be 5890 angstrom. It's a very childish question, you should say. So only thing is you have to remember the conversion, that is 1 nanometer is equal to 10 angstrom. That is the main thing which you need to remember. Then the mass of an oxygen atom is 16 mu. Then find its mass in kg. So 1 mu is 1.66 into the power minus 27 kgs. So oxygen, as it is 16 mu, which is given, therefore it's 16 into 1.66 into 10 to the power minus 27. That will give the answer as 2.657 into 10 to the power minus 26 kg. Then it takes a time 8 minutes for the light to reach from the sun to the Earth's surface. Its speed of light is taken to be 3 into 10 to the power 8 meter per second. Find this distance from the sun to the earth in kilometers. So time given, it's 8 minutes, that is 480 seconds, as the speed of light is also in seconds. And therefore, this one minute is converted into seconds, that is 8 into 60, that is 480 seconds, and speed of light is given as 3 into 10 to the power 8 meter per second. So the distance will be time into speed, and that is 480 into 3 into 10 to the power 8 meter per second, and that is 1.44 into 10 to the power 11 meters, or you can say 1.44 into 10 to the power 8 kilometers. Meter divided by 1000, therefore that will give the distance in kilometers. Then a vernier has 10 divisions and they are equal to 9 divisions of the main scale in length. Okay, it is the main, if the main scale is calibrated in nanometers, or sorry, in millimeters, what is its least count? Okay, the least count can be calculated by using the formula that its least count is equal to length of 1 main scale division minus length of 1 vernier scale division. So as we know, the 10 divisions of the main scale coincide with 9 divisions of the vernier scale. Therefore, the one vernier scale division is equal to 0.9 main scale division. Therefore, LC, that is least count, is equal to 1 main scale division, that is 1 MSD, minus 1 vernier scale division, and that is 1 MSD minus 1 vernier scale division is converted to MSD. So that is 0.9 MSD. That means that comes to 0.1 MSD, or 0.1 into, as it is calibrated in millimeters. So 0.1 into 1, that is 0.1 millimeter, or 0.01 centimeter is the least count. Okay. One thing I want to tell you, that you need to practice the formulas first, and then you can solve these questions very easily. You can put this the given things in the formula and you can solve it. The main thing is that you need to memorize the formulas. Okay, please pay attention to the formulas first. A boy uses a vernier calipers to measure the thickness of the pencil. He measures its to be 1.4 millimeter. If the zero error of the vernier caliper is plus 0.02 centimeter, that's positive zero error, that is, what is the correct thickness of the pencil? Now, correct thickness of the pencil is measured thickness of the pencil minus the correction, minus the zero error, that is. So, excuse me, measured thickness of the pencil is, we know it's 1.4 millimeter, and the zero error, it is plus 0.02 centimeters. So 1.4 millimeters minus 0.02 centimeters. Okay. This I forgot to write. Okay. So please forgive me for that. So correctness will be, thickness will be 1.4 minus 0.2 millimeters. Okay. And that will give it in millimeters, because that is in centimeters. 0.02 centimeters is, we should convert it into millimeter. That will help us to subtract. Same unit, you can subtract very easily. So 1.4 millimeters minus 0.2 millimeters, and that will give us to 1.2 millimeters is the correct reading. Now, next question. A vernier calipers has its main scale graduated in millimeters, and 10 divisions on the vernier scale are equal to the length of 9 millimeters. When the two jaws are in contact, the zero of the vernier scale is ahead of zero of the main scale, and the third division of the vernier scale coincides with the main scale division. Find the least count and the zero error of the vernier calipers. See, the value of one main scale division, it's given as 1 millimeter. See, it's in millimeters, graduated in millimeters. So it's 1 millimeter. Value of one main scale division is 1 millimeter. It's given. Therefore, 10 vernier scale division is equal to 9 main scale division. And therefore, least count will be value of one main scale division by the number of divisions on the vernier scale. Okay, so value of one main scale division is what? 1 millimeter by the number of divisions of the vernier scale is 10. So it will be 0.1 millimeter, or you can say 0.01 centimeters is the least count. Now, when the jaws are in contact, were brought in contact, the zero of the vernier scale is ahead of the zero of the main scale. That means the error is positive zero error, positive zero error. So that means the vernier scale is possessing positive zero error. Now, the third division of the vernier scale with the main scale coinciding with the main scale division. Okay, with the main scale division. And the total number of vernier scale division, we know it's 10. So zero error will be plus 3. Okay, positive, and the third division is coinciding, so plus 3. Therefore, plus 3 into least count will be the zero error, that is plus 0.03 centimeters. Next. In a vernier calipers, there are 10 divisions of the vernier scale, and 1 centimeter on the main scale is divided into 10 parts. While measuring a length, the zero of the vernier lies ahead of 1.8 centimeter mark, and fourth division of the vernier is coinciding with the main scale division. So find the length, and if the zero error of the vernier caliper is 0.02 centimeter, what is its correct length? So length of one main scale division is 1 millimeter, because this is, you can see it is written that in the vernier scale, there are 10 divisions, and the 1 centimeter of the main scale is divided into 10 parts. So 1 centimeter divided into 10 parts means 1 millimeter each. So length of one main scale division is 1 millimeter. Number of divisions of the vernier scale is 10. So main scale reading will be, it's given as 1.8 centimeter mark is so 1.8 centimeters. Now, division of the vernier scale, which is coinciding, is the fourth mark of the vernier scale, that is coinciding with the main scale. Then LC, that is least count, will be 1 by 10 millimeters, that is 0.01 millimeters or 0.01 centimeters. The length of the rod is main scale division, main scale reading plus vernier scale reading, that is vernier scale coinciding into least count. So that will be, main scale reading is 1.8, vernier scale division, which is coinciding, that is fourth one, 4 into 0.01. So 1.8 plus, this will be not my multiplication, it's a plus sign there should be. So 1.8 plus 4 into 0.01, that is 0.04 centimeter. That means the total length of the rod will be 1.84 centimeters. Okay, this is the observed reading. But the instrument is possessing a negative zero error, that is 0.02 centimeters. So the correct reading will be observed reading minus the zero error with the sign. So as it is a negative zero error, so 1.84 minus within the bracket minus 0.02. So that becomes minus into minus, that is plus. So 1.84 plus 0.02, that is 1.86 centimeters. Next is the pitch of the screw gauge is 0.5 millimeter and the head scale is divided into 100 parts. What is the least count of the screw gauge? Pitch is given as 0.5 millimeters. A number of divisions of the circular head is 100 parts, that is 100. So therefore least count will be pitch by number of circular scale, number of divisions of the circular scale. So 0.5 by 100, that is 0.005 millimeters or 0.0005 centimeters. Next question is, the thimble of a screw gauge has 50 divisions. The spindle advances 1 millimeter when the screw is turned through 2 revolutions. What is the pitch? What is the pitch of the screw gauge and what's the least count of the screw gauge? So number of circular scale division is given as 50 divisions are there. Now linear distance moved by 2 rotations, 2 complete rotations when we are moving, that's 1 millimeter. So pitch of the screw gauge will be 2 revolutions. So 1 revolutions, how much it will move? Half of millimeter, that is half into 1, that is 0.5 millimeter. Now the least count of the screw gauge will be pitch by number of circular scale divisions. So 0.5 by 50, that will give us how much? 0.01 millimeters. Okay. Next question is, the pitch of a screw gauge is 1 millimeter and its circular scale has 100 divisions. If in measurement of the division, in measurement of the diameter of a wire, the main scale reads 2 millimeter and 45th mark on circular scale coinciding with the baseline, find the least count and diameter of the wire. So pitch is given as 1 millimeter. And we know the circular scale has 100 divisions. So least count will be pitch by number of divisions on the circular scale, that is 1 by 100, that is equal to 0.01 millimeter or 0.001 centimeter. Now next thing is diameter of the wire. So for this, we take the main scale reading, which is given as 2 millimeters, and circular scale reading as 0.01 into 45, as 45th mark is coinciding. So 45 into the least count will give us how much? 0.45 millimeters. Okay, so that will be main scale plus circular scale reading diameter. So 2 plus 0.45, that will be equal to 2.45 millimeters or 0.245 centimeters. Okay, next is, when a screw gauge of the least count 0.01 millimeter is used to measure the diameter of the wire, the reading of the sleeve is found to be 1 millimeter and the reading of the thimble is found to be 27 division. Now, what is the diameter of the wire? And if the zero error is plus 0.005 centimeters, what is the correct diameter? Okay. So reading, first we take the observed reading, that is linear scale division reading plus the coinciding circular scale reading, circular scale into least count, that is circular scale reading. So linear scale reading is, we know it's 0.1. Okay, 0.001 is the millimeter is the least count. Okay. So the reading of the sleeve is found to be 1 millimeter. So that will be 0.1 centimeters. And least count is 0.01. millimeters, or you can say 0.001 centimeters. So 27, we convert it into centimeters to 27 into 0.001 centimeters. So that will give us 0.1 plus 0.0027 centimeters. So that will give us to 0.127 centimeters. And the true diameter will be now observed diameter minus the zero error with the sign. So 0.127 is the observed diameter, observed reading, and then the negative sign, that is minus, and as it is a positive zero error, so plus 0.005. And that will give us to 0.122 centimeters, the true diameter, the correct reading. Then a screw gauge is 50 divisions on its circular scale, and its screw moves by 1 millimeter on turning it by 2 rotations. Okay, it moves 1 millimeter by turning it on 2 rotations. That means in one rotation, that will be half a millimeter. When the flat end of the screw is in contact with the stud, the zero of the circular scale lies below the baseline, and the fourth division of the circular scale is in the line with the baseline. And the fourth division of the circular scale, in the baseline, and find the pitch, the least count, and the zero error of the screw. So first, number of divisions is 50, circular scale division is 50. So pitch will be distance moved ahead in one revolution will be 1 millimeter by 2, that is 0.5 millimeter. Least count will be pitch by number of divisions of the circular scale. That will be 0.5 by 50, that will give us 0.01 millimeters. As the zero error lies below the baseline, the flat end of the screw, when the flat end of the screw is in contact with the stud, the error is positive zero error, which the instrument possesses. Now, number of circular scale division coinciding with the main scale division is 4th. So zero error will be, excuse me, plus 4 into the least count, that is only 4 into 0.01 millimeters, or you can say plus 0.04 millimeters. Next is, when a screw has a pitch equal to 0.5 millimeter, what should be the number of divisions on its head so as to read correct up to 0.001 millimeters with its help? Given the pitch is 0.5 millimeters and least count is given 0.001 millimeters. So number of divisions will be, we know least count is equal to pitch by number of divisions. Okay, so interchanging, that is number of divisions, we don't know, we need to find out. So pitch by least count will give the number of divisions of the circular scale. So pitch is, we know, 0.5 by least count is 0.001, that will be equal to 500 divisions on the circular scale. Okay, next is a simple pendulum completes 40 oscillations in 1 minute. Find its frequency and time period. So given is number of oscillations of the pendulum is equal to 40 and time taken is 1 minute, that is 60 seconds. So frequency will be number of oscillations by time taken. So 40 by 60, that is 2 by 3, that is equal to 0.667 hertz. Or time period is 1 by frequency, second part, time period is 1 by frequency. So 1 by 0.667, that is equal to 1.499 seconds. Okay. Now the time period of a simple pendulum is 2 seconds. What is its frequency? What name is given to such a pendulum? Time period, we know it's given 2 seconds. So frequency will be 1 by 2, that is equal to 0.5 hertz. So the name of such a pendulum is seconds pendulum because it requires 2 seconds as a time period. Now find the length of the seconds pendulum at a place where G is equal to 10 meter per second. Take pi as 3.14. So we know time period is proportional to the square root of L by G. So proportional as is taken as constant as 2 pi. So T is equal to 2 pi L by G. That gives us T is equal to, in place of pi, we write 2 into 3.14. Okay, the root over L by 10. Okay. So to remove the square root, we make T square is equal to 6.2 into 3.14. That is 6.28 whole square into L by 10. So T square is equal to 39.4384 into L by 10. Okay. And that will give us 3.943 into L. So T, we know it's seconds pendulum. So 2 seconds will be the T value. So 2 square is equal to 3.943 into L. So L will be equal to 4 by 3.943. That is equal to 1.014 meters. That will be the effective length of the seconds pendulum. Now compare the time period of two pendulum of the length 1 meters and 9 meters. So T1 we know 2 pi L by G, that is equal to 2 pi 1 by G. 1 meter is the length. So T2 will be 2 pi L by G, that is equal to 9 by G. Okay. So if we remove this I mean, if it is like this 2 into 1 by G into 3, if we make it, then it will become 3 into T1. Okay, or you can say T1 by T2 if you do it, 2 pi is equal to 1 by G, or 2 pi is equal to 9 by G. T1 value and T2 value. So if we cross this is 2 pi is same, so we can cross this, G we can cross this, so what remains is root over 1 by root over 9. If we this cross, it can be also crossed, that root over crosses, so what remains 1:3. That means if we remove the root over, what remains 1:3, 1 by 3. Okay, so T1 by T2 is equal to 1 by 3. Okay. So the time period of the second pendulum is thrice of the first pendulum. Next is a pendulum completes 2 oscillations in 5 seconds. What is its time period? And if G is 9.8 meters per second, find its length. Time period is equal to total time by total number of oscillations. So total time is total time is given 5 seconds. So 5 by total number of oscillations is 2. That will be give us 2.5 seconds. Time period is 2.5 seconds. And now if G is 9.8, then T is equal to, we need to find out its length. So T is equal to 2 pi root over L by G. So T we know 2.5 seconds. 2 pi is 3.14. So 2 into 3.14 root over L by G is 9.8. So if we solve, we can get 1.55 meters. Okay. So this is the thing we are solving it. See, 2.5 into equal to 2 into 3.14 root over L by 9.8. Okay. So this is the way you can solve this question. Next question is the time period of the two simple pendulum at a place are in the ratio of 2:1. What will be the ratio of their length? Excuse me. Let's say T1 and T2 are the time periods of the two pendulum. L1 and L2 are the time lengths of the two pendulum. Now we know that time period is proportional to root over length by acceleration due to gravity. So as acceleration due to gravity is same, G at a similar place. Okay. So G cancels. Okay, so what remains is T1 by T2 is equal to root over L1 by L2. Now we remove the square root. So L1 by L2 is equal to T1 by T2 whole square. Okay, T square by T1 square by T2 square, you can say. So T2 we know 2. Time period is 2, and for T1 is 2 and T2 is 1. So 2 by 1 root square whole square. So 2 square is 4 and 1 square is 1. So L1 is to L2 is equal to 4:1. Okay. Next is it takes 3.2 seconds for a pendulum bob to move from mean position to one end. What is the time period of the pendulum? Okay. See, so what happens for this oscillation from one mean position to the other, you need 0.2 seconds. Okay, so in this above figure, let O be the mean position and A and B to the extreme position to which the bob will travel. Now, according to the question, O to A is equal to 0.2 seconds. O to A is 0.2 seconds. Then again, A to O is again 0.2 seconds. From O to B is again 0.2 seconds, and B to O is again 0.2 seconds. So what will be the time period? As it is known, the time period is equal to total time taken by the pendulum to move from the mean position to one end and back to the mean position, and then to the other end, and again finally coming back to the mean position. So that will become time period is equal to 1 plus 2 plus 3 plus 4, that is 0.2 plus 0.2 plus 0.2 plus 0.2. That will be equal to 0.8 seconds. Now, how much more does the bob of a second's pendulum take to move from one extreme of its oscillation to the other extreme? Time period of the second's pendulum, T is 2 seconds. So time taken to move from one extreme position to the other extreme position of the oscillation is equal to T by 2. That is equal to 1 second. See, for second's pendulum is 2 seconds, but time taken to from one extreme to other extreme position of its oscillation is 1 seconds. Okay. So this is the end of this chapter. Completed this physics chapter. Go through this. If you have any doubt, please write in the comment box, or you can also refer to my email ID, that is kasturi74@gmail.com. I promise you to reply you as soon as possible. Okay. So go through this, and for my next videos, for getting the notification, you need to subscribe my channel. Okay, if you have not subscribed yet. And if you are liking the video, press the like button, share with your friends so that they can also be benefited from these videos. And don't forget to meditate before sitting to the studies, sitting to your daily routine. Okay, and that will help you to increase your concentration. Okay, and also plan your day in a very smooth manner. Okay, so thank you for watching, and have a good day.